So my name is Vojta. I work with Google here in Mountain View, and I work on the AngularJS team. And that kind of implies that I'm crazy into testing and stuff. I think I started writing tests or playing with this idea of automated testing about 3 or maybe 4 years ago. And usually when I get into something, I just do it totally. So at that point, at the time, I would just write tests for everything. You know, I wouldn't wake up without having a unit test for it first. And I remember I was doing, it was at grad school, I was doing like final exam from artificial intelligence class. It was a coding task, like implementing some agent to play poker game in Lisp. And of course, I would write unit tests first for that during the test. So when my teacher saw that, he was like, dude, you're insane. And I mean, I guess he was right, but I've been kind of doing this since then, and it really works. I think it's a really effective way of developing. And as I said, I wrote a lot of silly tests, a lot of useless tests that doesn't test anything actually. I also wrote a lot of tests that are really difficult to maintain, and I had to change them anytime I change anything else. And then I sort of realized that testing is really not about writing tests, but it's more about writing testable code. And after a while, I realized that, you know, there are certain patterns, like design patterns, that you actually start to following and start doing because it makes it easy to test. And that's what I want to talk here about. You know, I would like to share these things with you guys, like what I found working for me. Basically, a couple of design patterns that makes the code easier to test. And also, you know, it turns out that it's not just about easier testing, but it also makes your code better in general. It's easy to reuse. It's easy to understand. So, what is the plan? The plan is introduction. That's something that's happening right now. Then I want to just quickly show you Jasmine, a testing framework, and Karma, test runner, because then I will use these two things heavily during the example. So I just to make sure that we are on the same page. And then is the core thing that I want to show you, and that's I got three sort of design patterns, and I have like hopefully live example that I will show you how the refactoring actually makes it simpler to test. And then bonus, hopefully we'll get time for it. I hope so. It's I would like to, if we have time for that, I would like to show you Angular test suite, which is in general really fast. And I think there are just few tricks that we do, and so I want to show you these tricks. All right. So first, is there anybody who thinks that testing is, let's say, wasted time, or you don't think that testing is good? Or we are all, because then we can skip the next slide. You know, why would you ever write tests? Which is basically, I put a couple of reasons and benefits of testing, like, you know, proving that the code works, which is something that you would do anyway. Like, even if you don't test automatically, you do that manually. You probably change something in your app, and then you try it if it actually works. But I think the most important for this talk is the last one. And that's better design. I really think that writing tests taught me a lot about architecture. I think I changed a lot of the patterns that I was using when designing architecture, and I actually think it's really good. I think it's way better. So I think testing makes you write better code. Okay, so first, I'm gonna show you. I want to show you quickly Jasmine. Jasmine is a testing framework. So it's a DSL for you to describe your tests, right? It looks, let's say this is some function for, can you see the screen? Is it big enough? Maybe we can make it bigger. All right. So let's say we have plus function, really hard one, and we want to test it. So Jasmine has, the first important thing is describe. That's a function that's a DSL for defining a suite, right? The suite is like a list of individual tests. And the cool thing about Jasmine is that it's really expressive, and it's really, you can even read it as a story. And I think that's how it should be. You know, I think tests should be simple to read. It should be like just telling a story. So we say we're going to describe plus, and then you can even nest these describes to create like structure of your specs. And then we're going to use another DSL, and that is it. And that's basically the definition of a concrete spec or test, if you like. So, and again, it's in this behavior-driven style. So we're going to say it's even readable. You can say it should sum two numbers, let's say, right? And then we have the third really important function is expect. And that's something that you use in order to assert that the result was correct or something. Because now in the test, we do something, we perform some operation, and then we assert that it does what we expected. So we can do expect plus function 1 plus 2 to be 3. Right. This is our first simple Jasmine test. I really like the fact, if you look at it, it's very readable and easy to understand what's going on there. I mean, this is a super simple test, but even if you use like good level of abstraction, you can keep even more complicated tests really readable. So this is how we can define our test. Then the question is how to run these tests, because that's why we write tests, in order so that we can run them and see the results, right? And so Jasmine comes with something like, we call it HTML runner, which is basically an HTML file. It looks something like this, where you include all the files, like here's my plus.js file, and then you open this file in the browser, and you see the result. As you can see now, it's undefined because we didn't implement this function. So we can implement that, return A plus B. I go back to browser, refresh, and it's green. But as you can see, this workflow is not good. Like Jasmine is great for like describing tests, but this runner is just something so that you can start. But moving back and forth between the browser and the editor kind of sucks, and it's not the best workflow you want. Plus, you need to this index.html. You need to maintain this file whenever you add new file. You need to update this file as well. So. Plus, it doesn't integrate well with continuous integration server, because it's not easy to get the results from the browser and stuff. So long story short, that's why we have our test runner Karma, which does exactly this. It does this. It runs these tests, and it gives us really nice workflow. So with Karma, I just do. Well, I should mention that Karma needs some configuration to know about your project. Like which browsers you want to use, where are your files and stuff. You can generate this config file using Karma init. It will ask you a couple of questions, like which testing framework you want to use. So we say Jasmine. We want to use Chrome. And now the good thing is that I can say I want to load all my JavaScript files in this folder. And then if I add a new file, I don't have to worry about that. And that's pretty much it. So let's start Karma. It's in command line Karma start. And what happens is that Karma starts a browser in the background. We don't have to worry about the browser, but that's where Karma will execute all these tests. And now, Karma is also watching all the files of my project. So whenever I change the project, it will run these tests. And I don't have to go to browsers to do something. So this simple test, look, I just do Command S, I save the changes, and it immediately executed the file. You can see it down in my command line. I'm also using Growl notification. So in my right corner, if I want to make full screen editor, when I save, you can see in the right corner it passed. If I, let's make +1 here, it fails, expected 4 to be 3, right? And I immediately see the results. And that's what Karma is about. Like, it has tons of other features. If you are interested in that, I will share some links at the end of the talk, like where you can, there's a screencast, how to do other things with Karma. But this is the basic workflow that we are going to be using. So Jasmine for defining test and Karma for running the test. All right. So now is the important part, because now I would like to show you these patterns. So now it's time to maybe wake up or something. Let me explain a little bit the code that I have here first, because I'm going to be using it the whole time. So it's probably, imagine we are creating some real-time collaboration app, maybe something like Google Docs, and there is some notification, like let's say, you want to notify other users or something. And so we have this notifier object here, and that's the object that is responsible for this notifications to other users. So whenever any component of my application wants to notify about something, it will use this object, right? It has a send method that you call, you pass some user object, and message that you want to deliver to that user. The kind of neat feature of this notifier is that it doesn't send the messages immediately, but it does something we call batching. Like, you send one message, it doesn't do anything. Then you send another message, it doesn't do anything. Then you send third message. It's like, oh, okay, now I take these 3 messages and ship them at once, right? That's one of the features that it does. And the low-level, connection to the server, like probably opening some socket or something and stuff like that, that is in a separate service. That is in a service that I called backend. And in this case, you can see I just, in the constructor, I just throw an exception, because this backend, that would be something that is expensive, something that probably opens the connection to server, or basically stuff that we don't want to do in unit test. And that's why I put this exception, so that we know that we are not doing it during our testing. And this notifier, as I said, it uses the backend to actually send the message on the wire. And here on line 2, the notifier creates this backend that afterwards it will use it. Plus there is one more thing it needs to do. Before sending the message, it needs to encode this message. And this is like trivial example, it's not a real app, right? So my encoding is just prefixing the string with a secret. In real app, that would be some complicated algorithm. So this is something we want to unit test, right? We want to make sure that this encoding algorithm works well. And that's why I extracted it into a separate method. Like that's a common trick. If you want to test something separately, you can extract it into a method, and then it's easier to test this behavior. So I already did this. And let me show you my unit test for this. It's Jasmine. It's exactly the same thing that you saw before. And here on line 14, I basically instantiate the notifier, and then I expect that I do encode message, and I expect this message to be encoded. That's fine. That's exactly what I want to be doing in this test. That's expressive and describes the intent. But check out this. Like this boilerplate code that I have to do, because if I don't do it, then what happens is my test will fail. And it says I'm sending the request because that's the real backend, right? That's what we don't want to do. And so what is the problem here? Well, it turns out that unit testing is all about being able to instantiate a single unit without the rest of the system. That's what unit testing is all about. You need to make this simple, because that's what you will do all the time in unit testing. And that's exactly the problem here. Because here, I don't need the backend at all. I just want to test message encoding. But because the notifier needs this backend just to instantiate itself, it's a problem. I need to mock this somehow. I need to monkey patch the constructor and all these craziness. So the solution to this problem is using, it's called inversion of control principle or dependency injection. And that's basically about separating the assembling and wiring all these components together from the actual logic. So this notifier, that's where the actual logic is. And we want to separate this instantiation out from this notifier, because it should not be responsibility of the notifier. The notifier, now the notifier needs to know where the backend is and how to construct it, right? And that creates very tight coupling. So what we can do with the inversion of control principle, we would just pass it as an argument in constructor rather than creating it inside the notifier. And now, I don't need this code anymore. Like I can remove this. The test is passing. And my test is simple because the instantiation of the object is simple now. Right? So what did we do? We separated the responsibility of creating object outside from the notifier. And it turns out that this is really, it's not just good for testing, but it's good for, this code is way easier to reuse because it's something, we call it, it's loose coupled. Because the notifier doesn't need to know, is not coupled to this particular implementation of backend. Before that, if I want to use the notifier in some other application, I need to use the same backend as well because it was hard-coded. But once I separated these things, the only thing that the notifier says is I need something like backend, and I don't care what version it is. So you can take this code into other application and use the same notifier with a different backend. Okay. Another thing or benefit that this pattern has is that all the dependencies are more explicit. So now if you look into constructor, you can see you can see what the dependencies are, right? It's more explicit. The constructor can even serve as a documentation. You look at it and it's like, okay, in order to instantiate this class, this object, I need a single dependency. I need a backend. Before, it was like, oh, there's nothing. I don't need anything. And then in the background, it would do some nasty things. So it's more explicit. And therefore, at least for me, I think it's easier to understand as well what the code does. All right. So that was inversion of control or dependency injection principle, which separate assembling from actual logic and therefore makes the code easier to reuse, easier to maintain, and easier to test as well. I think this is really one of the most important concepts. So I want to make sure that it makes sense Does it make sense, guys? Yep. So I'm gonna fast forward this code a little bit. And as I said, this code, this notifier, it does this sort of batching where it doesn't send all the messages at once. And so I added a test for this. I added 2 tests for it. And these tests are, let me see. I'm testing, probably this one is better. I'm testing that it should batch multiple messages into a single call, right? So I create some mock version of my backend. I instantiate the notifier. Ignore this part for now. And then what I do is I send the first message, and I expect that the backend, the real service for sending the message was not called, right? Because I wanted to batch the multiple messages together. Then I send another message, and I expect the backend to be called, because that was second message, and here this argument here is configuration. What is the batch limit? So I set it to 2, and this is, I think, pretty readable test what it is doing. Okay, but check out this. This test is failing, and it's failing on this line, on line 46. It's failing because it expected this mock method not to be called, and it actually got called. So I'm like, okay, there's something weird going on, but I can actually show you another feature of Jasmine/Karma. If you want to execute just single unit test, you can change it to init, and then when I save it, it executes just this one test. But here's the mystery, because the problem is that if I execute this test on just alone, it passes, right? So this test that was failing before, if I executed just this one test, it actually passes. Look, like, if I execute all of them, it fails. It's this one. Send should batch multiple messages into a single call, right? It's this one. And if I execute just this test, I can put console log to show you that it's really executing this one test. Executed one test of 4, and it passes. And sort of like weird bug that, you know, and it can happen very often. And, you know, it's the same thing as if you execute tests in different order and suddenly it passes or failed because of that order. So do you have any idea what's wrong with this? Like, I can show you the code or the test. Do you have any ideas what might be the problem? Yeah?
The queue isn't preset on the notifier?
Yeah, totally. So basically any time, like, I'm not saying every time, but most of the time, whenever you have any problems with, like, you know, different order of tests change the results or stuff like that, it's almost always because of a global state. Like, global mutable state is a problem. And what is the problem here? Well, here we have the queue where we actually put the messages before we send them. And the queue, we take this queue from this notifier.queue, which is defined somewhere here. And that's basically global state, right? So what's happening inside the test is that this first unit test, it creates notifier, which puts a single item into the queue. And then when this second test is executed, it creates a new notifier, But because it's using the queue from the global state, it has the same instance of the queue, and therefore, even sending first message is already actually second message, and therefore it calls the backend. So what is the proper fix for that? Well, not using global state, like not using global mutable state. So in this case, it looks like we could just define new array anytime we are creating this object, and that would, I'm pretty positive that would be enough to pass. Yes, now the test is passing. But the problem is that there probably were reasons why somebody who wrote this code would be doing this. It could be, maybe there is some status indicator that shows some UI thing, some UI component that is showing how many pending messages we have, right? And this component needs this queue in order to see how many messages there are. And so the solution was okay, let's have this global queue that basically anyone can access and anyone can see. Right? That's a pattern that I've seen many times. And here are the problems with testing. If we were in Java or some language where we can have multiple threads, you could execute tests in multiple threads to make it faster. And then these sort of issues would be way worse. It would be totally crazy and difficult to debug. So anyway, this means the fact that there is other component that wants to see this queue. That means that this queue is some shared service or something. So we can make it a dependency as anything else, right? And rather than putting this shared dependency on a global state and then everyone having using it, we can make it explicit. It's very similar to the first thing that we were doing, to the first refactoring. So we will make it, let's put it as a dependency, an argument to constructor. That means that it's a responsibility of the creator of this notifier to create some queue. So in our test, we need to pass let's pass empty array. But that would solve even the use case that we had, right? Because now, when we are assembling this whole system together, we would create queue, maybe just empty array, and we would pass the same queue to the notifier, and we would pass the same queue to this UI component that shows the pending message number, right? And that's one of the tricks how you can avoid global state. Again, it's kind of, all these tricks are kind of related and kind of similar. They are still on the same thing, like making dependencies explicit and making it simple to instantiate object, and making it loose coupled. So now again, we removed one of the dependency of the notifier on the rest of the application. It's explicit dependency. So again, all these refactorings make the code easier to understand and easier to refactor, easier to maintain and reuse in different parts of our different systems. Do you have any questions? No? What is the time? Okay, very good. Okay, so third principle or design, it's not design pattern, it's more like rule that I want to show you is something that is called the law of Demeter. I don't know if you heard of that, guys. It's not important, the name is not important. But what it is about, well, let's see these two tests. For instance, the one that we've been just playing with. I can remove this console. And watch this. I'm testing that it batches multiple messages into single request, right? And as I said, Jasmine makes these tests really nice and readable. And so I want to keep it that way. Like I want to keep it expressive and easy to understand. No, I don't want to update. Thank you. So I create the mock backend, and I create the notifier itself. You know, that's all fine. That makes sense. Even those things, that totally makes sense because that's what, you know, that's kind of expressing what I'm doing. I send single message, expect that it's not called, send second message, expect that now it has been called. That's cool. But how about this? Like all this junk, like, why do I have to do this? You know, like just, I'm sending here the message, and the problem is that I need to create some user details object, and I need to create user object that returns this user detail object, and then it has some email. And if you look into the implementation of this method, what I really need is just the email. That's all I need. Right? Can you see it? Like this method, all it needs is email. That's where it's going to send the message. And I'm getting some user object, and I'm getting some details from it, and then reading email. And so the law of Demeter is basically about loose coupling. It says that every object should only know the minimum amount of information about the rest of the environment. So in this case, it says it should only know the email. Because this is again tight coupling to the whole environment, right? Because now the notifier is coupled to the fact that there is some user object that has get details method, and this method returns some object with email. So again, if you want to use this notifier object somewhere else, you will end up you will have to simulate this sort of structure, right? You will probably, because in the other project, it's more likely you're not going to have the same user with user details and stuff. So you will have to create some wrappers or something. I mean, there is a solution for that. But better refactoring is to basically, you know, instead of passing the whole user object, pass just the email. That's what this method really needs. And then we can refactor this test. We can just say, you know, just pass the email here, user. Well, actually, you know, user. Oops. And something. So now it's gonna fail. Let's refactor this one as well. You can see, like, as I'm typing, as I'm saving, the tests are being executed in the background. I don't have to do anything. I immediately see the results. I think that's pretty cool because that kind of gives you, like, you know, kind of new workflow where you can use testing as a developing tool rather than something else. And so let's refactor this. Let's just pass email, and we don't have to do this. And now the tests are passing, and I can remove this junk. And so my test becomes way more expressive and, you know, easier to see what's going on, right? Does it make sense? We can remove this as well. All right, so these were the three things that I really wanted to show you. That was inversion of control, or dependency injection, which is about separating the assembling and construction of object and wiring them together from the actual logic, so that you can easily test this logic. Plus, second thing was try to avoid mutable global state as much as you can. I think state in general, like mutable state in general, is kind of source of troubles. That's why functional programming is cool. But at the same time, I don't think we can create any cool interactive apps without state. So I guess state is fine, but it's good to avoid global state because that makes a lot of problems. And it's better to make it explicit, make the dependencies explicit as we did, refactoring so that it's explicit, every component has explicit dependencies. And last thing I showed you was the law of the meter, which is about loose coupling and basically providing each object the minimum amount of knowledge that it needs to know in order to do its job. So that's basically every time you see something like something dot something dot something in your method, that smells like that's against this law. I mean, laws are so that we can break them, but not in testing. That's a different world. This law was not designed by government. It was designed by nature, I guess. So, I don't know. Anyway, there are many other principle and design patterns. For instance, not doing work in constructor that can really help you a lot as well. Because again, it all boils down to being able to instantiate objects easily. So if you don't do any expensive work in the constructor, it's going to be easy. Or I don't know, composition over inheritance. That's another typical thing that I realized that since I started doing testing, especially in JavaScript, I almost don't use inheritance. I use composition, and most of the time I think it's better. If you care about this kind of stuff and you want to see some more stuff, I think let me bring up the links. This is the last link. I will probably send this out afterwards. But the last link is a link to Mishka Avery's blog. It's kind of old. He doesn't update it. But it's really cool. I think it's a really valuable source of articles about how to test and how to write testable code. So a lot of principles like the ones that I showed you are included there. And I think we have still a lot of time, but I would much rather do some sort of discussion and questions, and maybe you have some concrete problems, that we can talk about. Oh, we've got some questions on the top. Cool. Where can I see that? Ken, I don't think I see the actual questions. Please. Oh, okay, I see it now. Yeah, I got it. Thanks. How would you write tests and design the part of your app that has to do the actual wiring initialization of your objects? Okay, that's a great question. So if you follow the first principle that I showed you, the inversion of control or dependency injection, you basically end up with having all these nice objects that are easy to unit test, and then you have probably some huge main method that does new this, create that, and put it as a constructor argument there, basically assembling the whole thing together, right? This code is something that I typically don't unit test, but you want to have some higher level tests, some functional tests that actually test that the app assembles together and that it works together. Something that I would really like to mention to this question or to this topic is you can use dependency injection framework for that. right? I think it's good to separate this inversion of control principle or dependency injection principle from actual dependency injection framework, right? Because dependency injection framework is if you follow these rules and you separate these things, the instantiation from the actual logic, the dependency injection framework is the thing that can do the assembling part for you, basically. So rather than having it imperative code, like create this and then pass it there, you can just declaratively specify the dependencies of each component, and then the dependency injection framework will assemble that together. That's exactly what's happening in Angular, for instance, right? You don't have to do these assembling because Angular has dependency injection, and it does that for you. So how to answer your question, how do I write tests for this? It's going to be higher level tests, so probably some functional tests. You can even have like something like higher level unit tests that maybe test just part of your app, not the whole app, but maybe a bunch of objects together, and you can assemble these objects in sort of unit tests just to make sure that it works. But in general, I think functional tests and higher level tests are for testing this wiring. Okay, here is a long question. What is the best way to isolate components that cross language boundaries? Example, say I have two components that talk to each other through AJAX. One written in JavaScript and one in Python. Do I need to read and repeat the question, or can everybody see it? And just you're good. Okay. What about?
It looks like they're saying, "Hey, I need to talk to a backend, and I'm expecting a response." Something like that.
What about just creating more? Okay, so the second question that's about functional testing, and I think let me explain one thing that I kind of believe in, or kind of like. I don't think it's like you have unit test and you have end-to-end test or functional test. It's not like that. I think it's just the whole scale of levels where you can test. So you can start from like really low level unit test. Most of the stuff that we were doing were pretty low unit tests where you really test just single unit. And you can go up. You can like construct subparts, like subset of the whole system, maybe more components talking together, and you can go higher and higher to have maybe your whole app testing. And then you can go even higher and test like integration of this app with other components, maybe with other apps, like with other services. Like in this case, there is a web app that talks to some Python backend. And so you can have even, very high level integration tests that test this communication. And I'm not sure I understand this question. Like, yes, you can mock out any of those parts, but
Can you say, make the call here instead? Here's the expected hey, here's the test data response. I think they may be after a question like that, possibly. Or
Yeah, we do that. There's a tool called Sign-In that does that. You can create like a fake server, and it will respond to AJAX requests. But then like there's not a good way, it seems, with JavaScript to like what happens if your actual API changes and your tests don't. So they continue to pass, but in
yes.
reality it doesn't really work.
Yes, sign-on is a nice.
Repeat the question.
The question from the document, or? No, it was actually answer. We have a great audience here that is actually doing answers, which is great.
Like for the next one.
Yes. So what you described is you can pretty much re-implement fake version of your backend in JavaScript or something. Like Angular, for instance, have HTTP mock for that, or you can use Sign-On, which is a spy like mocking framework. Jasmine has spies for that as well. It's not that Sign-On is more like advanced, but you can use that as well. And you always keep balancing between these things. Like yes, at one side you can re-implement your backend in the browser, and then you don't need the real backend, right? And at the other side, you can use the real backend completely. And I don't think there is like any correct answer, because as you said, if you re-implement like fake backend inside your browser, then if you change the real backend, your test with this fake one will still pass because you didn't change the fake backend, right? So I think you need both. I think you want to have a couple of really high-level integration tests that actually test with the real service. And then if you have some concrete bug or some concrete little feature that you want to test and you know that you can like extract, you can test it without the backend, then you mock this part of the backend and you test just this little thing. I think in general, I would say I always try to cover every bug or feature with the lowest possible test. So if there is a bug on Angular, for instance, the first thing we do is we write a test for that bug that fails, and then we fix that test, right? And you always, rather than writing an end-to-end test for it, you try to write as lower test as possible because it's faster, and you don't need to have like that many high-level tests testing every single detail, because if you are low-level, you have better access to these things as well. So I don't think there is a single answer to solve this. It's more about like scaling. The third question, how about integrate Karma with continuous build like Jenkins? Does it use a JavaScript engine that's compatible with most browsers? All right. So Karma uses real browsers. Right? So it doesn't, there's no JavaScript engine, no other JavaScript engine in Karma. I mean, it runs on Node.js, but it doesn't use Node.js for executing the test. So you can use it with Phantom.js, for instance, if you want to do headless browser testing. But by default, I've been using, for instance, Chrome, right? How to integrate Karma with Jenkins? That is simple. We do that on Angular CI server, for instance. Karma has a special mode where you pass flag single mode, and then it basically, you start it, it runs all the tests, and immediately exits, and exits with proper exit like status code based on if the test failed or succeed. And it also has a special reporter for Jenkins. It has a JUnit reporter that generates XML results that Jenkins then can display. In the same way, it integrates with TeamCity or with Travis CI, or I guess most of the CI servers, because most of the CI servers would consume JUnit XML test results. So I hope that answers that question. Any code coverage recommends? Okay. So I personally actually don't use code coverage that much, but I guess it's good. Like anything is good. Anything you have is good. So, because with code coverage, if you have really low code coverage, it means it's bad. That's bad. But if you have very high code coverage, it doesn't mean anything, to be honest. You know, because it's not about like the code coverage is nice, but it doesn't necessarily mean that the tests are good. I think it's important to write good tests that they're flexible enough and test a single thing, are expressive, and I think that's more important than having like I don't have advice like saying, oh, you need like 90% of code coverage. Like you can have some rules like that because it definitely helps, but I don't think it's I can write you 100% code coverage and it will be totally useless. I wrote a lot of tests like that in the past.
So I guess my question is, I guess my question was more, is there a code coverage tool that works with Karma or JSON?
Oh, okay. Yes. There is a code coverage plugin that it uses Istanbul, which is some library for JavaScript. And yes, you just say, okay, use code coverage, and it will generate code coverage. It can, I'm not aware about the details about Istanbul, but it can generate either HTML reports or the LCOF format. And so yes. Any recommended dependency injection frameworks for Node.js? I wrote one, so I guess I should recommend that one. I don't know. I wrote one dependency injection framework for Node.js because of Karma. I needed a dependency injection framework, and so I went through all the stuff that was out there, and it was not doing what I want. Because honestly, I realized that very often people say that this is dependency injection, and it's actually not. So it's npm. The npm module is called just di. You can check it out. It's really lightweight dependency injection, and it's very similar to the dependency injection that we have in AngularJS. All right. Well, we have still some time, so I guess we can do the bonus. Unless you guys have some more questions. Okay. So the bonus was, let me show you. I mean, we built Karma basically for us to use during development of AngularJS. And whenever I demo Karma to anybody, I usually use Angular itself. So I'm going to show you this. I'm going to start Karma in my AngularJS project. I mean, in Angular itself. And the reason is I want to show you this. We have over 1,800 of unit tests, and Karma can execute these tests in like 3 seconds on the real browser. Right, so I can really execute these tests on every file save, if you like. And this is something, I mean, come on, like, is there anybody who has like thousands of unit tests that can run in like a couple of seconds? Because this is usually, it's a really good demo, like people really like it. It's like, wow, you know. But to be honest, it's not that much about Karma. Like Karma is definitely about workflow, and it's definitely optimized to be fast. But the fact that Angular's unit tests are fast is not that much about Karma. It's more about the way these tests are written. And so I want to try to explain a couple of these tricks that we are using to make these tests fast. So first thing is all the stuff that we already talked about. You know, the code is well designed with using dependency injection and stuff, and that enables you to do very low level testing. You know, that allows you to instantiate single objects without the whole environment, without a lot of dependencies, and that, you know, if you have thousands of tests, then this can actually make a difference. So this good testable design allows you to test really low level, and that's important. That can help you make tests way faster. Second thing is the DOM in browser is slow, right? I guess you've heard that before. But so what does that mean? Well, first trick is make sure you separate the view from logic. I mean, that's all, you know, MVC, like everyone knows about that. But it's still, I can still see that very often that it's not the case. So for instance, AngularJS can help you with this a lot because Angular has this two-way data binding. And the two-way data binding basically creates this sort of border between the view and logic. And so most of the Angular apps has actually a pretty decent separation of these two things. And the reason why you want this with regards to testing and with regards to making the test fast is so that you can test all the logic without the DOM. You know, if you want to test some directives in Angular, you know, like custom elements in DOM and this kind of stuff, of course you need DOM. Like there's no way around that. You can't test the UI stuff without DOM. But the point is that if you separate these things, then you can test the logic, the code that actually doesn't need the DOM. You can test that fast, and that's enough. You know, because we can have like thousands of unit tests that is without DOM, and these are fast, and then we have 1,000 unit tests that are probably a little bit slower, and they're using DOM. So separate concerns so that you can test the code that doesn't need DOM without DOM. Plus then, the next step, the code that actually needs DOM, as we described, any sort of view, UI components, or directives in Angular, it turns out that very often you don't need to append these DOM elements to document. And that's something we do a lot in Angular unit testing. There are definitely hundreds of tests that do DOM manipulations. But I think there is like maybe like 10 unit tests that actually append the stuff to DOM. Probably more, but not that many. And so the thing is that because you can create, you can do document, create element, and put stuff into this div or something, and then play with it, and it's gonna work. And the thing is that if you don't append it to a document, then the browser doesn't have to render it, and therefore it's gonna be faster. So unless you need it, don't append it to document, and it's going to be, again, faster. And only in some cases where you really need to append it to document, do it. Because there are certain operations where you really have to append it to the DOM. You know, if you have like UI widget that needs to know like its size of the box of the div or something, you need to append it to document. Otherwise, browser will give you zeros all the time, and your component probably won't work. You know, or if you are doing with jQuery, like is hidden, is visible, and stuff, jQuery would do crazy things like what is the size of this component? Is it visible? And if it's not in the document, it will say it's 0. So jQuery will say, oh, it's not visible, and stuff like that. But these are kind of details. So as long as possible, don't append these things to document, and it's going to be faster. And third thing is, it's kind of tricky to explain. So I'm getting a little bit nervous because I've already tried to explain this thing a couple of times, and I always failed. But just keep trying. Most of the browsers are written in C or C++, right? Like the rendering engine, like WebKit or Blink or Gecko or whatever, is written in C or C++. And the JavaScript is executed as a JavaScript. And so your code in JavaScript has separate memory heap from the C++. And it's kind of two separate worlds. And there is this context switch between these two worlds. Because browser is rendering, it's rendering, and then user clicks something. And so it's like, OK, let's fire this DOM event, and let's execute this event listener or something. It's in JavaScript, so let's execute this JavaScript. So it jumps to the JavaScript, executes these things, and then it goes back to the browser, to the C. And there are objects that you need to use some object, especially DOM objects, in both worlds, right? Because you need DOM objects in the C world in order to render the page. And you need them in JavaScript in order to read and write, change the CSS attributes and stuff. And so there are like wrappers, it's called binding, for these C objects. There are like bindings to expose these objects to to JavaScript. And then, no, it's not important. The important is that this context switch can be expensive, and especially because there's always a little bit of rendering and stuff. So the third trick I want to share with you is how to avoid this context switch. And it's related to set timeout, because set timeout is actually, that's one of the ways how to do this context switch. If you have an asynchronous API, if you do, for instance, set timeout 0, right? And that will basically schedule this function to be executed in the next turn, right? You are in JavaScript, you do set timeout 0, and it will put this function to some queue, and then it will switch the context to C, it will render something, and then once it gets back to the JavaScript, that's when it executes this function that you just put into this queue through set timeout. And so this trick is to not do this context switch. I have simple, no, where is? Typical example is any asynchronous, like testing any asynchronous API. So let's say maybe we are testing XHR. Like in Angular, there is HTTP service, which is responsible for sending requests to server. So let's say we are testing some service, some controller that needs to communicate with server. We don't wanna talk to real server during unit testing, and therefore we have some mock version of this HTTP service. And this mock version probably has API like expect request to this URL and then return this sort of data, right? That's cool. And now, this HTTP service, or the service that is responsible for sending these requests, is asynchronous. In your production code, it's asynchronous. And what you could do in test, you could make it synchronous, like immediately, because you have the fake data already there, so you could immediately return the values and it would be fine. It's not good. Don't do that. Because if you have API that is asynchronous, and then you test it with, you fake it, you mock it with synchronous, it's not good. Because basically, I feel really strongly that if the API is asynchronous, it should be just asynchronous. You know, and if you mix these two things together, you can get into really bad issues that are difficult to debug. So that's why, even in testing, when mocking these things out, you still want this API to be asynchronous. So basically, even my mock, HTTP mock, should be asynchronous. And one way how to achieve that is using set timeout 0, right? I send a request, and this mock version will do, oh, I have this cached response, the fake response, but I'm not going to return, I'm not going to call the callback immediately, but I'm going to do set timeout 0 and call the callback then. And you're fine. You are asynchronous, which is cool because the code is still asynchronous, so it's kind of stable. But the problem is that you are doing exactly this context switch to the C. And that's, in this trick, I want to show how you can avoid that. So this code is some fake set timeout. This is very similar to what we're using in Angular. Set timeout, calling set timeout will just take function and put it into queue, right? That's the. And then we have this special API called flush. And what this does, it basically takes the queue and executes all these functions. This is really trivial implementation, but it shows the purpose, I hope, right? And here is some code that is using this set timeout, right? You do set timeout, and it just increments counter, nothing special. And it does set timeout 0, so that this async increment is asynchronous function. And now we want to test this. So we call async increment, we called async increment, and we are expecting that the counter is 0 because that's a test that it is asynchronous, right? This function is asynchronous. That is important because we want the API to be consistent. We want it to be asynchronous even during unit test. So this assertion is testing that it didn't get incremented yet, and that therefore it is asynchronous. And what we do here, this is the important part. We do set timeout flush. So rather than relying on the browser to do this context switch and executing the function later in the next event loop, we we are in charge and we control this, and we explicitly say, now I want you to flush the queue. And then we expect, yes, it got incremented, but asynchronously. So the trick is that we still have asynchronous API, because for everybody who would ever call this async increment method, it is still asynchronous. It behaves asynchronously. But in our test, we are kind of wrapping this whole thing, and we are resolving the set timeout queue manually, like this, without relying on browser. So for browser, it's kind of synchronous code. Everything runs in single run. But for the caller of this function, it is asynchronous.